Look, honestly, I feel that if you want to be in these three areas of computer engineering, computer science, and software engineering, you do need the maths.
Everybody is talking about computer science, all our toppers. And the big question here comes to me and maybe a lot of parents along with me is, what is the difference between these three?
Computer science is the very first IT discipline in the world. Do you know that before the 1970s, there were people whose jobs were computer? The very first computers were human beings. What did they do?
One of my friend, he's a computer science engineer and he calls me one day and I'm saying, what are you doing? He said, I'm working with BMW. What kind of jobs in terms of the future jobs one can look at in IT?
You really need to look at what skills they are looking for. We have a job platform in Australia called seek.com where companies advertise what jobs they are looking for. 75% of the employees there, software engineers and computer scientists, because you are building algorithms to matchmake. By the way, that also means that all the dating apps are basically software engineers being matchmakers.
Yes. Hello everyone, welcome to our show, Spin the Career Wheel with Nikkhiel Malhottra. Today we have with us Professor Shanton Chang from the University of Melbourne. We are going to discuss about the career opportunities in the information technology sector. We are also going to understand the difference between computer engineering, computer science, software engineering, AI, data analytics, and a lot more. So stick around, join us for the discussion. Hello, Professor Shanton. Thank you so much for being at the show.
It's a pleasure. I look forward to our discussion.
So, Professor Shanton, what is your area of research?
Well, it's an interesting one. I am from the School of Computing and Information Systems at the University of Melbourne, where we teach everything from computing to information systems. My area of research is actually information behavior. So what I'm interested in is how people use information, what they do with information, how they look at access, use, hide, share, encounter, create, hoard information. Because one of the things that people don't realize is that everyday life and everything that we do when we make decisions is really based on information that we receive. And most of the time, we receive all this information from online.
Correct.
Am I right? So that means that when you are looking at people who are engaging in social media, you're looking at people that are creating websites, TikTok, a whole range of stuff, we are really interested in how they access and use this information and how they then use the information to make decisions in their life. Everything from buying something for e-commerce through to their health, through to educational technologies. So I'm interested in how people not only use information, but also how they interact with technology.
Got it. And what do you teach?
Yeah, so I teach in particularly the Master of Information Systems, which is really looking at how IT and information technology is really used by businesses, organizations to improve the way they work, to improve return on investment, but also in a safe information security safe way, right? So a lot of it is not just IT, it's also about humans using and engaging and adopting technology and how organizations can benefit from it.
That's very interesting. So coming from an Indian perspective,
Yeah.
I'll tell you, after year 12th, 1.4 million Indian students appear for this exam called as IIT JEE, which is a test to go to IITs in India. And do you know which subject the toppers choose?
It has to be computer science.
That's
We're talking
what.
about India
Everybody
here, right?
is talking about computer
Yes,
science. All our
yes,
toppers
yes.
want to do computer science engineering. And the big question here comes to me and maybe a lot of parents along with me is, what is the difference between computer science, computer engineering, and information technology? What is the difference between these three?
That's a very good question to ask. I'm going to step away from IT for a moment and computer science and talk about medicine. Now, this sounds very interesting,
yes,
right?
Yeah, this is very interesting.
Now, if you think about a student studying medicine, right, people understand that there's a difference between GP, surgeon, pediatrician,
Yes,
right?
yes.
All of these different areas. You don't ask somebody and think that they are all interchangeable. You don't ask a surgeon GP questions. By the same token, you don't ask a GP to perform surgery. Am I right?
Right.
That's really important. Now let's talk about IT again. In the same way, there's a whole range of technology areas, not always interchangeable. Okay, so that's the basis of our conversation.
Yes.
So when you look at computer engineering, in many places, that's really talking about the hardware, right? So some places might even call it telecommunications. Some places call it electronics engineering. So it's really building the hardware, right? So people who like to tinker and build with the hardware, sensors, chips, all those sorts of things, right? They might even be interested in looking at the networks, right? That's computer engineering, sort of broad area, electronics engineering.
Right.
That's quite different to software engineering,
Correct.
which is what runs the computer, all the apps, the websites, the software that we use to purchase things and all that.
Correct.
So one is the hardware, one is the software. That makes sense.
Yes,
right?
That's a very commonly terms used here in India as well. Hardware, software.
Yeah. And students who are interested in IT, usually, they will kind of know, do I want to play with the software or the hardware? But then there's everything else in between, right?
Okay.
There's computer science. Computer science is the very first IT discipline in the world.
Okay.
Right? Computer science. Now, the interesting things, do you know that before the 1970s, there were people whose jobs were computer? So the very first computers were human beings. What did they do? They compute.
Oh, I was very interesting.
Think about compute as a verb. Right?
Yes.
They compute, therefore they are the computer.
Yes.
Right?
Yes.
So this is really interesting. And if you don't know what a computer does, go and watch this Hollywood movie called Hidden Figures.
Okay.
Okay. And there was this bunch of women who were computers.
Okay.
Right? That helped NASA get the moon landing. Right?
Interesting.
There were amazing mathematicians, there were computers, and they were the first people who worked with the IBM machine that was bigger than the size of this room that we're in, for example. So now computer science are people who play with algorithms. Okay? So they are the hard coders. They are really interested in computer coding, looking through things like algorithms, looking through things like AI, right? So when we talk about the thinking of how do systems work out what it is that they are doing, that's the computer scientist. But a lot of people just say they want to study computer science, but that's really coding. There's a lot of coding in there. It's algorithms based, it's machine learning.
Right.
We talk about AI. That's all kind of in that area, right?
Correct.
Which is quite different to software engineers, because software engineers take all the work that these coders do and the algorithms, and they make it applicable so that they're more applied. They're creating websites, they're creating apps, for example, they're creating softwares. Without the software engineers, you and I, if we want to use computers, will need to know how to code.
Okay.
Right?
Okay. Yes.
But we don't imagine if the whole world has to learn how to code to interact with computers. That will never happen. All we do now is press buttons.
Correct.
Right?
Yes.
Who is creating that? That's software engineers.
Oh.
So, and in some countries, they are called, therefore, the back end and the front end developers.
Yes.
Back end are the people who kind of build all the algorithms.
Who are the computer science grads?
Yeah, computer science grads. And front end are the people who develop apps, websites,
engineers.
that sort of stuff. So and then there's another term, just to add to, they call full stack developer. That means they can do both front end and back end.
Full stack developers.
Full stack developers, right? And some students like that. Others like to just do front end. Others like to do back end. Broadly speaking, those are your categories. So there's hardware, and then the software side, there's computer science, there's software engineers.
Right.
Those are the big three when you think about what it is that these computer science people actually do.
So this is primarily what I understand more around the coding. And then the big question to the students, like I'm talking for students who are in class 10th, 11th. A lot of students at their class 10th, they have this question whether to do maths or not. And a lot of students are afraid of maths. They don't want to study maths, but they want to be in IT industry. What do you think they should do? Or
look, honestly, I feel that if you want to be in these three areas, computer engineering, computer science, and software engineering, you do need the maths.
Okay.
Because you need attention to detail.
Got
right?
it.
It's really important. The attention to detail is what makes or breaks a good algorithm and a good software.
Thank you so much for this
That's
insight.
really important. The maths is actually very important. Does that mean that if you don't like maths, you cannot do IT? Now, let me just tell you that there's a whole bunch of people who are in IT who hate maths.
Okay, that's another important piece of information.
So that's very important. So you then start to look at other disciplines within the IT world where it starts to be less focused on the math and the algorithm. For example, there's a particular category where people just use the term IT as very inclusive of everything, the whole range.
Correct.
So that would even include computer engineering in it and information systems, which we haven't talked about yet. And they will use the term IT. Now, in my university, if you're doing a master of IT, for example, you could specialize in machine learning, you could or AI. You could specialize in user experience design or cybersecurity or distributed computing, which is a different way of coding things, right? And so when you look at that, the IT person is almost like the GP of the IT world. They are very good managers. They are able to bring different components and different skill sets to come in. So they're not just specialists in one thing. Although they have an area of focus, they are very good at harnessing all the resources in IT. Because in reality, when you look at an IT team, it's not one type of IT. All these different groups come together
and then
to
create
help
something.
solve the problem. It's the same. If you are going into a hospital, let's say, touch wood, right? You are not just looking for one type of medical profession. You've got the nurses, you've got the doctors, you've got the specialists. They all come together to solve a problem. And in the IT world and in IT companies, that's the same thing. Not everybody is the same in IT.
Got it. So that's so I understand within the IT industry, there is one particular set, which is computer science, engineering, and software engineering. And then there is another terms which people talk a lot about, which is around information systems, data analytics, data science, artificial intelligence. So what is this then?
Okay, well, first of all, artificial intelligence, right? The people who want to build AI tend to fall with the computer science group. That's the first thing. So you got to be a good programmer. Now, the other side, we're looking at information systems, data analytics, that sort of stuff. Okay, here I'm going to split into two for you. The data science type students, actually, it's, in a degree in data science, 75% of that degree is probably maths and stats. Right? You are doing analytics. And what are you analyzing? Data. So how are you analyzing data? Maths. Right? The IT side is basically programming to get the data. Right? Because so much of data now is online. So what it means is data science is you must really like maths. Even more than the computer scientists. The data scientists are essentially very good modern day 21st century statisticians who are very good at things like analyzing the data, visualizing the data so that decision makers can understand what's going on with the data. So the data scientists do programs that go and scrape data from the internet. Right? Then you've got terms, and I'm going to throw a whole bunch of terms at you. You've got things like business analytics. Yeah? You've got bioinformatics. You've got social informatics. All that is saying is that you are applying your analytics skills or your data science skills in different contexts. If you are looking at share prices and business and improving business data, you're in business analytics. You are using the same skills in data science and analytics in the business world. You have to understand share prices and all that. If you're a bioinformatician, what you're doing is you're helping scientists who are trying to understand the human body, for example. The human body is full of data. The curing cancer in the future is going to require understanding all these stats and what's happening within the biology and the bio data. And helping to analyze that is bioinformatics again, And then social informatics is people who try to understand what's happening in the social world. How do people interact? Social media analytics, right? And that's looking at how people interact in society, community, and so that's social informatics. But at the core of that is data science and data analytics. Does that make sense?
That makes sense.
So that's one whole set. And the final one that you're talking about is information systems. Now, it's really interesting. I teach in information systems, and sometimes I tell my students it's actually not just about computers. It's about information and it's about systems. So one of the things that I tell my students is that the earliest information systems was in the building of the Great Pyramids. There were no computers back then.
Yes.
Right? But if you're trying to build a pyramid, you need a lot of information. And you need to think, where am I going to get all the stones and the rocks? Where am I going to get the manpower to pull this together?
Right.
If I get all this manpower to do this, then what's going to impact on my agriculture? But at the same time, I need to feed all these people. So it's a whole system of information that you need to manage, right? Except there was no computers.
Yes.
In today's world, information systems is about how you manage all that information with the aid of computers.
Okay.
Right? Everything from B to B, business to business, the supply chain, how it gets out to your customers, all this is driven by information and systems of information. You see what I mean?
Yes.
So information systems are people who bring together the understanding of how technology is used and how businesses or organizations are run. So actually, most of them don't even do maths.
Yes.
But they're working in IT because it's IT, business process improvement, all that sort of stuff. We still want our students to understand database. That's very important.
Yes.
Yeah. We still want them to understand a bit of programming just so that they can talk to the software people how to design things. Got
it.
Let me share with you an interesting story of one of my alumni. She spent a whole month at the back of a police car in Melbourne every night. What was her job? Her job was to help redesign the dashboard in the police car, because when the police go around, they have to enter data of what they're seeing, all the problems, all the issues, right? And then that data then has to be collected and then analyzed to improve. Right? But when you are driving and talking and doing whatever, the dashboard has been really easy to use.
Yes.
Right?
Yes.
So my information systems consultant student was studying what the police are doing and trying to help design what the dashboard should look like. She gets all that data as an information system specialist.
Right.
She then gives it to two groups of people, software engineers, to program it, to make it usable, and user experience people to make it easy to use with one hand while driving, while focusing.
Correct.
And the software engineers will help build that, but the computer science people might help the underlying algorithm. And the computer engineering people might build, is it a new machine that needs to go in there? Or can we adapt an existing machine into the car? So you see this whole team of people working on that.
And again, I'm coming back from a career perspective of a 10th class commerce without math students or a art student who really want to be a part of IT industry. So maybe information systems can be one area which they can pick up at a bachelor's level.
Absolutely, or even at the master's level. So my master of information systems, I have had students come from nursing.
Oh, that's very interesting. Example. So you're saying you become a doctor?
Nursing or whatever. So for example, I have had people who have come from nursing who have then gone on to help redesign health systems within hospitals.
Very interesting.
Right? Because technology is used everywhere.
Everywhere these days.
It's everywhere. Don't just think that if you are studying IT, that you just focus on going into Meta, TikTok, Facebook, IBM. No. Our more IT students work in non-IT companies than in IT companies.
One of my friend, he's a computer science engineer, and he calls me one day and I'm saying, what are you doing? He said, I'm working with BMW.
Absolutely.
And I'm like, God, they make cars.
Yeah.
And
if you look at an electronic vehicle, it's essentially a very sophisticated piece of computer. Think about it.
Yes.
Right?
These days, yes.
And if you look at the biggest car companies in the world, there is software behind it. Right? So this is the thing. Don't just think, it must be an IT company, when in fact it is not. Even when people are looking for jobs, right? We have a job platform in Australia called seek.com, where companies advertise what jobs they are looking for, right? 75% of the employees there are software engineers and computer scientists because you are building algorithms to matchmake
Correct.
People with jobs. By the way, that also means that all the dating apps are
Yes.
basically software engineers
Yes.
being matchmakers.
Yes. Yes. Yes.
Because it's all algorithm, right? Not to say, but so this is the thing, we don't think about it, but IT is everywhere.
IT is
and
everywhere.
studying IT, knowing your strength is very important because, like you said,
Yes.
not everybody is suited for computer science, but they might do user experience design,
Correct.
or information systems, or software. They are all very different. You don't ask one to do the job of another.
Yes, and good you mentioned that user experience. I saw that in your university you
Yes.
have this computer science as a major
Yes.
in Bachelor of Science
Yes.
as well as Bachelor's in Design.
Yes.
So I can do a Bachelor's in Design with a major is computer science.
Yes.
So what is the difference
What's the
between
difference?
these two?
Yeah, that's a very good question. So the major itself, if you were to come into the Bachelor of Science, the computing and software systems major is exactly the same as
Okay.
the major of computing and software systems in Bachelor of Design.
Okay,
Right?
so you end up learning the same computer science logics.
Subjects.
Yes.
But the entire degree is not just the major,
Yes.
right? So you might do 12 subjects for that major.
Correct.
Then there's another 12 subjects, right? And in our degree, we require that you do 5 to 6 subjects that's not in either science or design. So you could do business, you could do law, you could do music, whatever. Right. But then still there's another 6 to 8 subjects or whatever. Right. Then the question is, what do you do? So in the science subject, you could augment, strengthen your computing and software systems major with things like data science, if you like maths, or physics, right? Or some of the basic engineering subjects because you want to build the system.
Yeah.
In the design one, you can do user experience design. You could do graphics design, right?
So user experience is all around how an app is looking.
That's right. That's
Yes.
right. So either way, you are getting the software skills, but you're applying it in different ways.
Yes. Yes.
Make sense?
Makes sense.
Yeah.
Makes sense.
We even have Bachelor of Commerce students because in our degree, we require them not to do all the subjects from commerce.
Correct.
So some of the commerce students will do 3 or 4 subjects in basic programming.
Okay.
That gives you the added advantage of being not just a business and commerce student who also knows how to do technology.
Very, very interesting.
Yeah.
Very
Yeah.
interesting. Yeah. Another question. It's a big question, because in computer science you have 3-year degrees, you have 4-year degrees. So at an undergrad level, how should a student decide on whether I should do a 3-year degree, then a master's, or maybe.
So let's be clear here. When you look at the 4-year degree here, right? The 4-year degree tends to be an engineering degree.
Yes.
Right? So you're looking at computer engineering or software engineering. Computer science is usually a 3-year degree.
Should be a
it's normally a 3-year degree, right?
Yeah.
So why is there a difference? The difference is engineering. Computer engineering and software engineering, they are engineering,
Yes.
right? Computer science, information systems, user experience, data science, they are all not engineering. What's the difference? Engineering degrees require an accreditation.
Yes.
With engineers, for example, for us, it's Engineers Australia.
Correct.
In fact, for us, the students who do our engineering degrees, for us, is at the master's level, not just undergraduate. And our students get accreditation not just with the Washington Accord in the US, but Engineers Australia in Australia, but also the European URACE accreditation. We are one of the very few institutions that has all 3 of those.
Okay.
Right?
And all 3 are very prestigious.
Oh, very prestigious.
accreditations,
That's why it takes a bit longer. longer.
Yes.
Now, what's the difference? So when you look at an engineering degree in many countries, it's just a 4-year straight engineering degree. We took a decision at the University of Melbourne a number of years ago to say that when you look at the engineers of the 21st century, they are more than engineers. Right? So we don't just teach all subjects in engineering. We teach you engineering, but also business skills, if you want to go that way. We teach you engineering, but also more project management, if you want to go that way. We teach you engineering, but also understanding economics.
Okay.
If you want to know that way. So, for example, people in energy systems have to understand that it's not just the hydro power electric, but also be able to convince people why that is worth investing in. So the economics becomes very important. So at the University of Melbourne, our engineering degrees is the 3-year Bachelor of Science degree, followed by a 2-year Master of whatever engineering.
Okay.
Right?
Okay.
So that is possible. If you just want to do computer science, you can do a Bachelor of Science in Computing and Software Systems and finish there.
And what happens then? Will they be able to get into the workforce?
The good news is that yes, they do, right? But a lot of them want to specialize further.
Okay.
So a lot of them then come on to do the two-year Master of Computer Science, Master of Software Engineering, Master of IT, or Master of Information Systems.
Got it.
Because that means within that 5 years, you are not just good at your technical skills, but also be able to apply it to multiple different disciplines and areas.
So you more or less become like the term you use, the full stack guy who can do almost
not so much full stack, but being able to apply your technical skills in different contexts.
Different contexts.
Yeah. So we have students working in the health area.
Okay.
We have students working with hospitals. We have students working with governments, with the telcos, telecommunications. We have students working in the financial sector. We have students working for the Big Four. Right?
Okay, yeah.
And they have got this suite of technical and non-technical skills that enable them to be versatile. And one of the key things in the 21st century is we want our students to be very versatile. Right?
Yes,
You know that jobs are
That's
changing.
the need of the hour.
Absolutely. Why would you specialize to the point where there is one specific area only. And it's very risky, right? Technology is moving so fast.
Yes, and the way world is changing, I'm sure there might be some careers who don't exist today, might be in existence 10 years back.
Yeah, some jobs haven't been invented yet. So we are training our students for the eventual need to learn and be adaptable to different disciplines. Right? So I have students working from everything from government to the zoo to museums. Right?
Great.
And you would never think, why did you study so hard in IT to work in a museum?
Yeah.
They are paid really well.
Yes.
Right? Because if you go to some of the best museums around the world, it is highly interactive. You got the app, you got the interaction, and you can continue to interact even after you've left the museum.
See?
And that's a big thing. And so people are paying good money for that. And governments love IT students.
Yes.
You know, in Australia, we don't have enough students doing IT. Unlike in India, you have so many students wanting
All
to do IT.
the toppers want to do IT. That's what I told you.
It is the opposite problem in Australia.
Yeah.
So, you know, it's a great opportunity for students
For
who are
international
in that space.
students.
Yeah. But the important thing is you have to find which IT are you. Don't go into the wrong area.
Yes.
Or you're going to hate it.
Yes.
I hope that today's, we've talked a little bit about the difference. Yeah.
Right. So one last thing on what kind of jobs in terms of the future jobs one can look at in IT.
So again, when you go and look at jobs, sometimes it's actually very hard because the job titles can be different for different areas. You really need to look at what skills they are looking for. I'll give you an example. We have another discipline called digital infrastructure engineering. Nobody knows what it is, but it is one of the areas with great opportunity. These are people who not only do software and data analytics, they are dealing with live data. Okay. What's the difference between live data? It's not just e-commerce where you buy something, right? You press a button, you buy, it's delivered, whatever. Live data is, imagine people who are trying to control traffic lights around the whole of Delhi.
Got it. And how sensitive it is.
So you need to think how many cars are going by. It's not just the cars, it's also the tuk-tuks, it's also the delivery drivers, it's also the big trucks, all going at the same time. So it's also about the life, how many seconds it takes, people crossing at the same time. They all occupy different amount of space. There's only a limited road.
Yes.
So you are trying to deal with live data, GPS, all that sort of stuff. So these are very highly in demand skills.
Yes.
Right? Whether it's in defense, in government, in civil engineering, digital infrastructure engineering is how software. So that's a way of the future that 5 to 10 years ago, nobody would have thought. But now it is a real thing. But then students are like, oh, never heard of this. I don't want to do it.
Yes.
But actually, here we are saying when you are in IT, you're always constantly thinking about the future and how it's going to change.
The next steps.
Yes.
Yeah.
So some of these jobs don't exist yet. But the reality is there will be jobs. What the title is, we're still not sure.
But there will be jobs.
But there will be jobs.
Because I know all the governments are talking a lot around smart cities.
Oh my gosh, yeah.
And what is that?
Well,
What
smart
is all
city,
that?
the people who do digital infrastructure engineering are going into smart cities.
Because
All
every government is spending a lot of money, investments into building their smart cities.
Yeah, let me tell you the best example, right? The first year digital infrastructure engineering students, one of their assignments is imagine there's a zombie outbreak. What is the government going to do in the city? So they have to run simulations, how to avoid, how to prevent, you cannot do it in practice. So it's almost a digital simulation to work out what's the best policy and what do you do to ensure that it can contain this pandemic, right?
Yeah.
So it's really the way of the future, and thinking about what it actually means when you're studying IT. It's not just I'm sitting there in my little quiet room just programming away. It's actually a very dynamic area. And the biggest thing about people who work in IT is you don't just work alone. You have to work with teams. You have to work with people, right? And some IT people don't like working with people.
Correct. They just want to be a good coder, and they're saying,
but
okay,
you're
give me
still working with a team of IT people.
Yes.
Right?
Yes.
And some people just want to talk to people all the time. So then they are the ones who sit in the back of police cars, or they go and look at how it's applied. So that's very exciting for them, but they don't want to do the coding. So they get the requirements and let the coders do it. Together, they are a team. Yeah.
Good. Thank you so much. And if you have any final thoughts around, my focus is, I'll tell you, when I thought about this topic, I was like, I know all the toppers know this is a great industry, but the students who are afraid of maths still want to be a part of IT. If there is any point of advice you want
to... if you're not interested in maths, but you still want to do IT, I always say that even if you're an art student, right? Art students and in humanities and sociology, you are really interested in how human beings collaborate, communicate, negotiate conflict and all that sort of stuff. One of the key things is that human interactions are now mediated by technology. That's very important. So you can't run away from the technology. You need to at least understand how the technology is impacting on human society.
Correct.
So you could be studying that, not the programming. And that is still an important digital skill to have. If you're in commerce, you want to sell online. Nobody should be doing a commerce degree that has zero IT. Right?
Yes.
Really need to think about things like search engine optimization, so that it shows up on ChatGPT, on Google, all that sort of stuff. But also, how do you improve the processes of the business to get better on return on investment on your technology?
So there has to be some component of the IT. Yes. While you are going to pick up your
absolutely. For us, even our medical degree, one of the biggest things they have to teach the medical students is data science. Why? Because how do you heal people? What medication works? What is the data telling us about what is most effective in what treatments? That is data science.
So what we are saying that a biology student who has nothing to do with mathematics has to still know how to use data. Use data. Yeah. That's true.
Right? Yeah. And that's all across multidiscipline. And this comes back to the fact that in the 21st century, nobody solves the problem with one discipline.
Yes.
So in our degrees, we ask students to combine different disciplines because that's how you become versatile.
Great. Thank you so much. Thank you so much for this discussion.
It's a pleasure.
Yeah, looking forward to have more discussions with you, Professor Shanton.
Thank you very much.
In your next India visit.
Thank you.
Yeah, pleasure.